Hello, this is Advent Code 2024. I'm Noah Mann, and I'm the author of FunctionalJ.io, a library that brings functional goodies to Java. I'll use this video to showcase FunctionalJ.io to solve Advent Code. Today's puzzle is day 12. All the code discussed in this video and the link to what mentioned above will be in the video description. Let's get started. Today's puzzle is called Garden Groups. We will be helping elves to fence off the garden based on the plant that they are planted there. So in this example, each character represents different type of plant planted in the garden. So A will be one type of plant, and B will be another type, C will be another type, so on. To build the fence, we need to prepare the material, and the cost of material is calculated by the production of the area and the perimeter of each plant. The example show that in this case we will have the section of the garden that we plant the plant A, B, and C, and D, and E, so on. So we will need to calculate the area. In this case will be 4, and the perimeter, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 4 times 10 in this case equal to 40, and this one will be 1 times 4. This one will be 4 times 1, 2, 3, 4, 5, 6, 7, 8, 4 times 8, which is 32. This one will be 4 times 10 equal to 40. This one will be 3 times 8 equal to 24. And when you sum them up, what you get is 772. So how would we solve this problem? Well, the question asks for the summation of the price, and the price is equal to area times perimeter. So the next logical step is to calculate the area. And we can do that using the flooding algorithm by going to the first characters, or go to any characters. And then if it haven't already been a part of a group, we just look around its neighbor. And for the one that haven't been a part of any group and we haven't visited, we just check if the plant that we plant in that position is the same with the one before. If it is, then we just include it in a group. So we add this in the group, and then we recursively do the same thing, so it will expand to that one and that one. Same go with, let's use B as an example. It will look for that, and then B will look around. There's nothing on this side, there's something on this side, then recursively call this, and it will look from there and then go there, and then it go back. Another word we can use recursive, and is equivalent to depth first search. That way we can determine the group of plants that are next to each other. Then we can count all the position and you will get the area. So now how would we determine the perimeter? The perimeter is defined by the fact that the plant in one position is not the same with the one next to it. Let's look at this example like here. So because this one is a group, right? So if we look at each of the position in the group, and then from that position we look around its neighbor and determine in each of the neighbor which one is not part of the group. So we found that when look at here is the H, so this one is not part of the group. We looked on this side, this one is not part of the group. We look on this side, B is not part of the group, but this A is. So we know that the perimeter for this first A is 3. Then we move on to the next one and do the same. The upper bound here is not part of the group. Lower B here is not part of the group, but this A is, right? This A also is. So if we continue this step, we will be able to identify that we have 3 here, 2 here, 2 here, and another 2 here. So the perimeter is equal to 10. So once we get the area and the perimeter, we can just multiply them together and sum them up. So let's take a look at the code. Because of this is a great problem, it will be helpful to have these classes. Position, which is the combine of row and column, and it have a helpful method like neighbors, which return the list of neighbors around it. It will be helpful later that it can be sorted, so we make it comparable. Then we have a class called grid. We take input list of string as a parameter. List of the string represent each line of the input, and each characters in that string represent type of plant in that position. So this script has a method like get character at the position. We can get all the position within this grid. Then we can find all the groups inside the grid. So here is a mixture of procedural and functional. So we have a set of visited position, and we only process the position that we haven't visited. And then for the rest of the position, we create a group. To create a group, we need to figure out what the character there and then find all its member. This will be a recursive call. You can see a little bit later. Once we get all the member, we only care about distinct position as part of the member. As I mentioned, find group member is a recursive functions. So we first check if the position already been visited. If not, we just go through all the neighbors. And then if the neighbors haven't been visited and has the same characters as the one we have in this group, then we recursively ask for the further members from there. So this will recursively go through, as mentioned above, and then we add all the members into the group members array, and then we return it out. Once we have all the members, we can create a group object which contain the grid and the members. The group object look like this, grid and members. Once we have the members, maybe it's good to rename it. Okay, then we can create the price of the fence by calculating the area and perimeters. So the area is just the number of member there. Perimeter is the sum of all the perimeter of each member. So to calculate perimeter of each member, we ask the member for its neighbor and filter only the neighbor that is perimeter. And that is the neighbor that is not part of this group. How many of those? We just return the size of that and then we sum them all. After that, we just multiply it with the area and we get the fence price. And this is the main function to calculate. So it's get the input, find all the group, and then sum all the fence price. That is it. I think the code is quite straightforward and it highlights the good mixture of object-oriented programming like this functional programming, which things like this or this, and procedural, which have the recursive and add things into builders. That is it for part 1. Let's take a look at part 2. In part 2, it turns out that the elves can get discount for the fence if we buy the material in bulk. And with this discount, we can calculate the fence price using the area times the number of size. So how would we resolve this problem? Because the question asks for the total number of price or cost, and the cost is equal to area times number of side. So we need to calculate the area. We already know how to do that from the first part. Now we need to know how to determine the side. The side is a bit trickier, and well, actually I have seen the video that explain how to do this super easy, but because that's not how I did it, I don't want to claim that. So I will tell you afterward how to do it. Let me explain you how did I do it. The way I do it is to consider all the edges. The edges is just one piece of the perimeter, right? You can call it perimeter, but in the code they call it edges. So this is the edge, this is the edge here, right? All the edge. And you will notice that multiple edges combine into a side, so like this one. So if we combine edges by some properties, we can determine whether or not they are part of the same side. So in order to do that, we need to check whether or not all the edges in the group is the same alignment. Alignment is a specific term in this code that I use to represent whether or not it's vertical or horizontal. And where is it? So in this case, in this first one here, you can see that this one is horizontal and it's between row 0 and row 1. So this edge equal to horizontal at row 0. In the code, we represent this a little bit different, but the concept is this. So for this edge here, it will be horizontal at 0 as well.
This edge will be horizontal at 0 and this edge also horizontal at 0.
So if we group it by this, we will get these 4 edges. Then the next step is to determine the location of the edge. So in this case, because the edge is horizontal, so the position is the location is the index on the horizontal position, right? So in this case, it's column 1, column 2, column 3. So in order for edges to be in the same group, it have to have a continuous position. And in order to do that is to sort these edges and then find the diff. All the diff have to be equal to 0. So that's a concept. Let's see the code. Similar to part 1, we will have the class position, which also can return its neighbor But now we have the method called edgeWidth. So it's a convenient method that when give the position that is next to it, we can create the edge. And the edge is defined as a two positions that are next to each other. To make it uniform, put the position that has a lower, either row or column first, because they are neighbor, right? So they are either on the same row or on the same column. So when we do this, we will get the sign. Then we have a grid. Just like before, it have characters at the position as a way to return all the position, just like before. And now we can calculate the group, which is pretty much exactly the same logic with before. So I'll go through this. Then we create a alignment. Alignment is composed with the edge direction, which is vertical or horizontal, and the position. In this case, the position refers to either row or column that the edge are next to. So if it's vertical, the position will be row, right? Because vertical edge separate cell on the same row. Horizontal edge will separate position on the same column. So here's a class called edge, which has position 1 and 2. There's a method to calculate alignment, which is direction and the position is on, and something called identity, which is a way to help us determine what side of this edge we want to know for the specific characters. Then because we're going to group the parameter by the alignment and also the identity, because the character is going to come into play here. So we create the side key as a key for the group. Then for the group, which has a grid and a position, we can calculate the fence by its area, and the number of side, we just go on all the edge, find all the edges, and the edges are perimeter basically. Then we convert the edge into a side, and because we're going to group by its alignment and the identity, once we group for each of the entry, we get the alignment and the edges. Then we determine how many continuous side for that particular alignment. In order to determine the continuous side, we just try to map the edges into its location and then find the diff and count how many times that the diff is not equal to 1. Let's take a look at this example. For these two, because there are two edges, right? And the location of the first edge is, let's count. So this is 0, 1, 2, and 3. So the location of this edge is 3, and the location of this edge is 4. So the diff between these two locations is 4 minus 3, which is 1. And when we try to find the diff that is not equal to 1, we will get nothing. So the size of that is 0. There is no separation between this group. So it's one edge. How about this group of edges? So the location is 0 and 1. And this one is 6 and 7. So when we run through this, and whether or not the diff is not equal to 1, we will find one place where the diff is not equal to 1. And that is between this guy and this guy. So we get 1, and we plus 1. That is 2 sides. A little bit complicated here, but I hope you can understand. So once we get the number of sides for each of the alignments, we just sum them all. So we get a total number of sides for that group. We can multiply it with the area, and we get the price of the fence. And then we sum all the price of the fence. Then we get what we look for, which is the cost of building the fence. As promised, there's an easy way you can solve this by just determining what is the corner of each of the group. Like for this example, there is 4 corners, and for C, there are 8 corners. The corner is determined just 2 sides next to each other with different alignment. It's much easier to calculate than what I did. That is it for part 2. I hope you can see that with functional J, you can write functional code when you need one, and it can mix with the way you do it before, like in object-oriented or procedural. So please check it out. Functional J is easy to include in your project. Just use this Maven or this Gradle code. It is in Maven Central. If you like this video, if you learned something from this video, please click like. If you want others to learn as well, please share. If you have question or disagree with mine, have your own solution, please put in the comment. And if you want to see more, please subscribe. Whatever you do, thank you so much for watching and see you again in next video. Bye bye.